Hey, what's happening, guys? You know, we've talked a few times in the past about capacitors. All the different types. You know, there's an electrolytic capacitor. There's a ceramic capacitor. Polyester capacitor. And these guys here are also capacitors. These are monolithic multi-layer chip capacitors, ceramic capacitors. Just a different flavor. And like here's a high voltage capacitor. I know you guys probably can't see that, but that's a 630 volt capacitor. And what they all have in common is they are simply two conductive plates, usually metal or some sort of metallized film. And in between them is an insulator called a dielectric. And that insulator can be anything from a vacuum to any sort of material you could possibly imagine. And if you look at this, I mean, the schematic symbol for a capacitor basically looks like that and shows you what it is. I mean, yes, there are other capacitor symbols denoting the different types of capacitors, but basically they're all the same symbol, just with a slight variation. So what I wanted to show you today was the actual makeup of a capacitor. And to do that, I've got this guy right here, which is actually a 3-gang variable capacitor. And we're going to zoom in and take a really close look at this, and you'll be able to see exactly how it works. All right, so here we are looking deep down inside this variable capacitor, and it is actually 3 separate capacitors. I have the first 2 hooked together to increase the capacitance. Remember, when we put capacitors in parallel, we increase the capacitance. And if you look here, you can actually see one set of plates here and a separate set of plates here. And in between them is the small gap. So our insulating material in this case is air. And as I turn this tuning knob, more and more of these plates, which are semicircular, mesh together. You can see very well here how that's happening. So here's one set of plates, and then there's the other set of plates. And then I can rotate. Now I'm unmeshing the plates, decreasing the capacitance. And now it is at its lowest state. You can see that there. And then by rotating it this way, I increase the capacitance by meshing the plates together. And they are as much plate material is as close together as is possible. And basically that is how every single capacitor works. 2 plates separated by an insulating material. Now, in the case of something like our electrolytic capacitor, it's just wound in a ribbon in a spiral fashion. Let's put this on a meter and take a look at it. All right, I've got the Unity UT61E here, which has a relatively sensitive capacitance section. And I'm going to null out the capacitance of the lead wires. And then I'm just going to connect my probes right across these wires that I have put together. And you can see that at our lowest state, we are at about 20 nanofarads. And as I mesh more together, now we're up to what, 26 nanofarad, 27, 36, until they're completely meshed together. And we're getting, let's call it 60 nanofarads. So all of this turning, all of this meshing and unmeshing is only giving us maybe 20 to 25 nanofarads of capacitance. And if we can actually measure the distance between those plates, let me see what we can do here. Okay, I know this isn't going to be terribly accurate, but it's close enough for our purposes. Now I have the plates completely meshed together, and if we hold a ruler up there, you can see that the plate spacing, when completely meshed, is just about 1 millimeter. Now, I know that sounds like a very small amount, but when you look at something like this, that plate spacing is probably going to be 1,000th of that. I mean, it's going to be so much smaller, which is why this teeny tiny thing can give us 8.2 microfarad, whereas this huge thing is only giving us a range, even if I ganged all three of those together, of maybe 60 nanofarad. So that's just a look, and this is a ALPS variable capacitor made in Japan, as Abe would say. I hope that gives you guys a little bit of a better idea as to the actual physical makeup and workings of a capacitor. So I hope you liked this, and if you did, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all the patrons. That's it. I'm out. Peace.